The New South Wales government is currently engaged in the biggest road building program in the state's history. Nearly $1 billion annually is being spent upgrading the road network. Improvements have meant safer roads, elimination of traffic bottlenecks, and cuts in travel times. With the number of vehicles using the road network growing rapidly, the government is concentrating on areas where there's heavy traffic volumes. The best example of this is the Sydney-Newcastle Freeway route, which is Australia's busiest road. In 1988, the freeway will be completed from Wahroonga on Sydney's North Shore to Wallsend in Newcastle. An injection of additional funding has resulted in work on the freeway being intensified in recent years. An example of this activity is the 13-kilometre section between Calgary and Summersby, which involves total expenditure of $18 million. This includes a number of interchanges which will provide access to and from the freeway. The target date for completion of this work is late next year, and from a cost-benefit point of view, it's regarded as the most valuable yet undertaken. Major benefits to flow from this work between Calgary and Summersby include a reduction of 14 kilometres from the existing route, elimination of the Peats Ridge section of the existing highway which has been plagued in recent years by serious road accidents, improved access for Gosford-bound traffic. Motorists will be able to use the freeway between Calgary and Carryong rather than a winding section of the Pacific Highway. At Summersby, an interchange under construction is designed to service both local and through traffic. Construction of twin bridges over Mooney Mooney Creek is a major feature of this section of the Sydney-Newcastle Freeway. Costing $19.5 million, the bridges stand 70 metres high. Their giant spans stretch across the deep gorge of the rugged plateau region north of the Hawkesbury River. Interestingly, Mooney Mooney Bridge is taller than the Gladesville Bridge, which stands 43 metres high, and the deck of the Sydney Harbour Bridge, which is 59 metres above the water. Each bridge is almost half a kilometre long, which will provide 6 lanes to north and southbound traffic. To complete the joining of the first bridge across the deep gorge, it was paramount to arrange the final concrete pour in the early hours of the morning to reduce stresses caused by temperature effects. At 2 a.m. on Thursday, August 29, 1985, the first of 8 truckloads of concrete arrived on site with the 28 cubic meters needed for the 2.6-meter-long final join. Initially, the concrete was pumped through a long elephant trunk-like pipe into the formwork on the floor of the box girder structure. During the next stage, concrete was poured down the inside of the bridge walls, which are almost the height of a 2-story building. Under floodlight, workmen began spreading concrete evenly about the floor area of the new structure. As the concrete was being poured, 4 strain gauges were strategically placed in the concrete to monitor the behavior of the bridge. Essentially, the gauges will check concrete stresses occurring in the bridge and relay this information to a computer inside the second bridge, which is also nearing completion. More than 100 such gauges will be used in the 2 bridges over the Mooney Mooney Creek. Apart from providing stress data, the gauges will also furnish the Department of Main Roads with valuable information for future bridge design and construction. The gauges placed in the body of the Mooney Mooney bridges are similar to those which have been used only once before in the Pheasant's Nest Bridge south of Sydney on the F5 freeway. The final pour at Mooney Mooney continued until almost dawn. This left workmen with the task of finishing off the deck of this first bridge, which will ultimately carry 3 lanes of traffic. The twin Mooney Mooney bridges, when completed in 1986, will form part of a vital link on the Sydney-Newcastle Freeway. It typifies the New South Wales Road Improvement Program, which provides better and safer motoring.